Moving on to question 6. You have another reaction between magnesium carbonate, can be used to produce magnesium oxide and carbon dioxide. It's like a decomposition reaction. Is it interesting? Yeah, kind of. Depends on what you find interesting. Alright, so mole ratio is very simple, just 1 to 1 to 1. What mass of magnesium carbonate? Mass is required, so I need to find the mass of MgCO3. This is the unknown. What mass of magnesium carbonate would be required to generate 100 grams? Again, mass is given because the unit is grams of magnesium oxide from this reaction. So you start with a mass and you need to find a mass. Now the only relationship that you have between these two species is their number of moles and the mole ratio in the mole ratio in the equation is probably more accurate. Mole ratio is not mass ratio. Please do not use this and then just say, oh, the mass ratio is 1 to 1, so it's just 100 grams. That is absurd. You need to find the number of mole first and of magnesium oxide, and then use the mole ratio to find the number of mole magnesium carbonate, and then convert it to mass. So there's no mass ratio. From the equation, the only thing that you can have is a mole ratio with N, not with M. So please don't invent new ratios because I've seen that before and it's never nice. Okay, so the first thing I'm going to find is I'm going to find the number of mole of magnesium oxide because I have the mass. Then the number of mole magnesium oxide is just mass over molar mass. You need to work out the molar mass of magnesium oxide, which is, I don't know, so 24 plus 16. Well, I guess I do know. So it's 50, 40, 100 over 40. What's 100 over 40? Something. I should know this. 2.5. Cannot believe I just did that in the calculator. But anyway, you can do that in the calculator. So 2.5 moles. So 100 grams of magnesium oxide is equivalent to 2.5 moles of magnesium oxide. Now from the mole ratio in the equation, you should be able to create, from the coefficient in the equation, you should be able to create a mole ratio between these two species. You want to find the number of mole of magnesium carbonate so that you can get the mass of magnesium carbonate. So it is a 1 to 1 ratio because the coefficients of these are just like 1. Therefore, the number of mole of MgCO3 is going to equal the number of mole of MgO, which is also 2.5 mole. And lastly, the mass of magnesium carbonate is going to be the number of mole of magnesium carbonate times the molar mass of magnesium carbonate. Another really interesting mistake is people just use the same molar mass but like 3 different species. That's not going to work out. Maybe I should write it here that the molar mass of MgO is, I think we got 40 before, 40 grams per mole. And I do not know what the molar mass of magnesium carbonate is. So I'm going to find it. So what is it? 24 for magnesium, 12 and 48. It's 84 grams per mole. So this is going to be 2.5 times 84, which is 210. So 210 is going to be the mass of magnesium carbonate that you need to generate 100 grams of magnesium oxide for question 6.